Hello, this is Dick Albin with the Federal Highways Resource Center Safety and Design Team. I'll be moderating this webinar today, and I've been with Federal Highways for about 7 years, but before that I worked for the Washington State Department of Transportation and also the New York State Department of Transportation. But most of my career has been focused on roadside safety and roadway departure type crashes. And one of the things that we've always lacked in that area is good information about where things are on our highways, things like guardrails and signs and things like that. And so I've been very encouraged recently by some of the activities that several states have taken on to improve the information that they have on their assets and their things that are out on the roadside. And so this is the second of 3 webinars that has been that are planned to talk about the use of LiDAR as a tool to help collect some of that information and give accurate roadside asset data. Today's webinar is going to feature information from the Minnesota Department of Transportation, and it goes over a effort that they had where they issued a contract designed at using the LiDAR in combination with imagery data to create a GIS-based inventory for barriers and plate beam guardrail. The goals of the project were, 1, to obtain filtered and classified mobile LiDAR data on several roadways in the Metro district, obtain Metro-wide data set of imagery compatible with the Trimble Trident 3D Analyst, then to use part of the processed LiDAR data for a 2016 design project. And then they also extracted barrier attribute and condition data from images created from GIS-based inventory and created a barrier asset management plan and determined the future LiDAR and imagery uses for MnDOT. This project came in under budget and provided a lot more information than traditional processes. In this webinar, we're going to feature 2 presenters from Minnesota DOT. The first is Trisha Stefanski, who leads the Infrastructure Asset Management Unit and is a member of MnDOT's Transportation Asset Management Plan Steering Committee and Software Acquisition Selection Committee. She also chairs the district's GIS committee, then we also have Brad Canaday, who leads the Metro District Surveys Group, and he leads the effort to incorporate the use of static and mobile laser scanning at MnDOT for asset extraction. So that's the webinar that we're going to be having today. We are going to be taking questions in the chat box. Hopefully you can see over in your control panel area that there's a chat box that you can type in questions. But we are going to let the presenters present the information that they have and then come back and answer questions at the end. So with that, I'm going to hand it off to Trisha Stefanski.
Well, I'm not Trisha, but I'm going to start this off. I'd like to welcome everyone that's viewing our webcast today. I'm Brad Canaday, and with me, as you heard, is Trisha Stefanski. And we hope that what we have to present to you today is of value to all of you.
Thanks, Brad. We also would like to definitely encourage you to ask questions and comments. So please send them our way by means of the chat box. And if you'd rather talk offline, we will have our contact information at the end of the webinar. So let's get started. What are we going to talk about today? In today's webinar, we'll go through the following topics. Brad will start with some fun facts, like it's cold outside today, about the Minnesota Department of Transportation, as well as some stats about the Metro District at MnDOT. I will talk about why asset management is so important to our agency and the nation and internationally, and then we will walk you through the Metro District Mobile LiDAR and Guardrail project. We will describe the project goals, tasks, and results, along with the project challenges, benefits, and some of our recommendations and lessons learned. Brad will talk about scanning work that has been accomplished within the Metro District, and we will both talk about our future vision and some ongoing efforts surrounding asset management and scanning. So thanks for having us today.
So we have 8 districts, as you can see, in the entire state of Minnesota, and we're in the Metro District. We've got a lot of lane miles, over 29,000, and with all of the lakes that we have in Minnesota, we also have a lot of rivers and crossings of highways, so we have over 4,700 bridges. And we've got over 410,000 signs, and we like to try and make it so people know where they're going here in Minnesota to get to our beautiful lakes and the countryside and the metro. As Trisha mentioned, we have some cold temperature here. I guess I'm skipping down a little bit, but cold temperatures here this morning. Currently, it's minus 11 here in the metro, which is minus 24 Celsius. And that affects our road temperatures, the extremes that we have, as you can see, from minus 15, which is minus 26 Celsius, to 100 degrees Fahrenheit, which is plus 38 Celsius. It puts a lot of strain on our system that we have here. We do a lot of construction projects because our roads tend to deteriorate, and as you can see, we have about 104 construction projects annually with a $326 million annual construction budget. That may change. Our governor is asking for $6 billion over 10 years coming up, so that figure might change if all goes well. And then we have a $128 million statewide operations budget. We also get a lot of snow, not as much as in other places, but 59 inches. We're saving a lot of money this year because we're at less than 24 inches, so we don't have to plow a lot this year. As I said, Metro is one of the 8 districts that we have, and that's where Trisha and I work. Trisha works in our Water's Edge building, which is kind of centrally located in that picture of the Metro there in the upper right. And then I spend time between the Water's Edge building, and then I have 2 survey offices that I oversee, one in the East Metro and one in the West Metro. And Metro District has about 14% of the state lane miles, so we've got a lot going on right in the Metro. And we've got over 50% of the bridges. We've got to get things up and over all these other highways because there's a lot of population here in the Twin Cities area. We've also got 50% of the sign panels, once again, helping you on your travels around the system. And then there's over 50% of the signal system, which is probably maybe obvious to everybody that with all of the highways and all of the traffic, we have to control it here, so we have all these signal systems. And then we also have about 50% of the statewide construction program. Now, we have a lot of area, as you can see on one of the maps there, that's outside the metro, but like, I mentioned a minute ago that we have a lot going on here, and it costs a lot more to build all the multiple lane roadways that we do here. And then we also have 46% of the annual operations budget here in Metro.
So let's just get into one of my favorite subjects, asset management. I'm probably preaching to the choir when I say that America's infrastructure is in serious need of repair. As Brad mentioned, $6 billion requested from our governor. We need to increase our budget, and at the current moment, we're not. So what does that mean? That means how do we support the replacement and maintenance work and all that has to be done? Our assets are getting older and older, and we're falling further and further behind. That's very obvious. You hear this all the time, too. We can't do things the same as we've always done. We need to try to extend the life of our assets, and how we do that is to do the right thing at the right time. So what is asset management? I like this. This comes from the AASHTO Subcommittee on Asset Management, and it kind of makes sense to me. It says that it's a strategic and systematic process, which is a planned and methodical approach. That's what it means to me, of operating, maintaining, upgrading, and expanding physical assets effectively throughout their life cycle. It focuses on business and engineering practices for resource allocation and utilization with the objective of better decision-making based upon the quality information and well-defined objectives. So we need quality information in order to sustain asset management. So what kind of information do we need? Lots of questions that can be asked by the general public or the person sitting next to you. When you have a beer at the bar, they know you work for MnDOT and they say, well, how many snowplows do you have? How many signs do you own? I mean, these are kind of common questions that we should really consider, that we really should know the answer to. You can see what types of assets, what condition are they in, excuse me, how long are they lasting, how much are we spending over the life of the asset, how much money should we budget for in the future, are we scoping future projects effectively and efficiently, are we meeting federal law? That one's kind of a big one. And that moves into the next slide, that in 2012, and I'm sure a lot of you are very familiar with MAP 21. So in 2012, President Obama signed into law the Moving Ahead for Progress in the 21st Century. And what that did is required agencies to come up with a more streamlined and performance-based transportation program. It really was job security for me, which I was grateful for. But it also, within MAP 21, each state is required to develop a transportation asset management plan. Now, keep in mind, I have to say that today we're talking about barrier, and the MAP 21 really asset management plan only requires pavement and bridges on the national highway system. But from the asset management conference I attended last year, and from a lot of different states and conversations, states are very much encouraged to include other infrastructure assets within the highway right-of-way. And I think it's only a matter of time before they will not just encourage it, but maybe require performance-based asset management for other assets. So examples of such infrastructure include pavement markings, culverts, guardrail, signs, etc. So MnDOT is one of 3 states that are developing a draft TAMP that will serve as a template for other states to use when they develop their TAMP. And we've been excited about that effort. We've spent a lot of time on it, but we've really made a lot of production too. Contents of the TAMP include the 7 items shown on the slide. And I don't want to spend too much time describing this effort. We have others at MnDOT that are that could do this part of the presentation much better than myself. But so if you want more information, just let me know on our TAMP, and it is on the website. But basically, I just want to point out that the first item in the TAMP is having an asset inventory and condition information. So without that, the remaining items will be very difficult, if not impossible, to determine. So inventory anyone, where is MnDOT Metro District in terms of our inventory? And again, I'm talking from the Metro District. A lot of these inventories we do have statewide, but the Metro District is where Brad and I work, and that's where our focus is. The assets in white have been inventoried, and the assets in yellow are either a work in progress or on our to-do list. We almost have a complete inventory of our assets. I started 5-6 years ago, I guess, and we've really done a lot of work on this. I specifically have really tried to do a lot of work on this, and that's something I wanted to mention in the presentation today, that it's really important, I think, to have a person sitting in my position called asset manager that can just continue to tackle these things, because if you don't have that point person, a lot of this will fall by the wayside. Let me hear. Fence is on the to-do list, so we don't have that one. But we do have a consultant project underway to locate and inspect roughly what we think is about 800 earth-retaining structures. We have general location information for our drainage structures, but we don't have an accurate attribute for our pipes within the structures. And Brad's going to talk about that a little bit later. And the last 2 items, which are starred on the list, are, of course, part of the project that we are going to discuss next. So as I mentioned, I was hired in 2009 to manage a $2.1 million sign inventory project. I came from Colorado, and I had some experience in Aspen, Colorado, with inventorying signs. So I was hired here to do just that, and what I was really taken back at and really glad for was that they utilized mobile mapping technology. I hadn't really seen it or heard of it before, and the contractor, which was Facet and SRF Consulting, had proposed that they would use mobile mapping technology. As most of you know, what it is a vehicle traveling at posted speed limits equipped with a laser scanner, high-resolution cameras, and GPS technology, and it captures LiDAR and georeferenced imagery. So the technology was, as I said, very new to me and very new to MnDOT. But the project was really successful, and I think, at the same time, Brad was really exploring mobile mapping technology. So we came together, started talking about it, and it also maybe, and again, maybe it was before this, but I feel that it started to get more discussed at the transportation, just in general, in the transportation industry. So it seemed like a perfect fit for our next asset collection, which was barriers. All right, the first goal of the project was to utilize the mobile mapping technology, and so I did write the request for proposals accordingly. The second goal of the project was to determine and obtain the attribution for the concrete barrier and plate beam guardrail, including condition data, and then we wanted to also obtain the Accurate Geographic Information System, or GIS, which I'll mention several times, inventory of the barrier that was easy to update but also easy to use. All of this, of course, was a snapshot in time. So we needed to create a plan that will keep this data updated and also look forward to managing the data in the future, as I've discussed in asset management. We also requested the contractor to obtain mobile LiDAR data for 3 different segments of roadways so we could utilize the LiDAR for upcoming design projects. And another goal of the project was to determine the future uses and applications for LiDAR, and we'll touch on this later. These are the tasks broken down by timeline. When I look at this, I was thinking, oh my goodness, this took a while. This was kind of a long project. But there was a couple things here. We wanted to keep the project costs as low as possible. So in this project, we collected mobile imagery throughout the whole Metro District, and then we collected LiDAR just in 3 different locations. And what that did is kept the project costs lower. The project budget was $250,000. That did not include internal staff time, but it also included software and 2 computers. So like I said, from start to finish, it took about 2 years to complete. But I have to say, even though everyone wants to move to Minnesota because of the climate, this project took a little bit longer because of the weather. We had a crazy winter, 2013, right? Yeah. So here are the project tasks and end dates for each task. We developed the consulting contract June of 2012. You can see the slide here. We purchased the extraction software, Trident Trimble Analyst 3D, in September. We obtained the contract deliverables by June, and then we started to do the barrier and condition extraction. And that took us a while. I only had 1 person, sometimes 2, I guess, working on it, but we spent kind of our sweet time on that. We created a management plan in March of 2014, and we internally displayed the barrier data in April of that same year. Sometimes it's nice to take your time, because then when it's actually complete, everyone's so excited about it. And we are ongoing programming more LiDAR projects. And again, Brad will talk about that.
Part of the reason why it took so long also is, kind of what Trisha alluded to, was that this was our first real dive into mobile scanning and imagery. So we were trying to grab contracts wherever we could get them, to pull out some specifications and take a look at it. And we came up with the specs that you see there on your screen. And for the imagery, we wanted it within a foot, because that was good enough for where the guardrail was going to be extracted from that imagery. And if the guardrail is here or 1 foot over, that was close enough. It's all going to be relative. And so, the video that we got in pictures was good. The accuracy of the LiDAR, we didn't know exactly how close we needed it. We know we needed it pretty close because we were going to use this for design purposes on a couple of the projects that we'll show you. And we needed to filter it out and then classify it in LAS format. But, being the first time in, we just didn't really have a good handle on how accurate we needed to get this. So, that proved to be good, and, because we got some good information, but not so good, and we'll talk a little more about that later. Our consultant, DTS, they were out of Florida. Mm-hmm. They met our specs, and they did a good job, so, there's no fault in that. And then, as you can see, we did some QA, QC things on that. The contractor did, and we did. And then, the project data was stored for 2 years in an off-site location for us.
So what was different about this project that I mentioned earlier is the fact that we did the extraction manually ourselves. So this is kind of a neat screenshot. Sitting at your desk, this is what you would see when the imagery is loaded within Trident Trimble 3D Analyst. And we set up what we do, it looks like a GIS layers and points. We created poly layers for the barrier inventory, and we created point layers for the barrier condition information. The extraction process really takes 2 clicks of a mouse, and you can see there on the lower left, it shows that's at assign support, where you click once and then the image jumps and you click a second time, and there you have your point. You take several points along a line to get a polyline, and you can see those on the concrete barrier and the plate beams left and right of the screen. So we collected polyline points about every 3 to 5 posts, and we also created other asset layers too that are listed, and we have used some of the other assets and some other extraction besides barrier for this. After extracting the data, we easily exported it into a GIS database. And I say there it's safe extraction because you're sitting at your desk, so you're not out in traffic. So here are some of the results from the project. And this slide basically illustrates the attributes on the left-hand side. We collected 15 attributes, some of which were the types of end treatments, if there was delineation present or not, the max and min heights of the guardrail, the average height. We could have obtained other attributions if LiDAR would have been included throughout the whole metro, but we decided that we were going to start with imagery. And as Brad said, 1 foot accuracy in the world. So we just really, but this can be kind of a tricky part, I think, of any agency, is determining and talking to key experts of how much data should you be collecting. What is the right granularity? Collecting more data is going to take more time, and it usually is going to cost more money. But you also want to be sure that you can answer the questions that are needed to be answered. So again, we were trying to keep the project cost low, and we didn't get into too granular of details. Some statistics on the right that I'd like to mention. We found out we had 483 miles of total barrier, and 227 miles was plate beam. And we extracted at a rate of 5 miles per hour. Kind of just good to know. We also extracted 250 condition points that were included. The condition points included things like broken posts for plate beam and spalling concrete. Those issues now have either been fixed by our maintenance crews, or we will be continuing to monitor the asset. And so we have a full report that we put on our Minnesota Transportation Research website, so please feel free. It's a little bit, that address is kind of a little bit harder to, but it looks like 11/3/2014 is probably when we completed that. So please check that out for more information on the barrier results. Out of this project, there were some challenges, and obviously we have some recommendations that we'd like to share. So it was a little bit tough for me to write the RFP and specify that MnDOT would be doing the extraction. Most of the systems are really proprietary, which that means that the file format that comes from the van goes directly into whatever software you have. So I had to say that, you know, we were going to use tried and true mill analyst and that we needed to have compatible file format. It worked out really well, but I think it was just kind of difficult to specify that. We also had a challenge of learning the new software, and it's always difficult, you know, no matter what. So we didn't have that expertise in-house, and so it took us a little bit longer to learn how to use it. Some of the image data that we got had to be recaptured because images were missing and others had sun glare, which, again, DTS did an excellent job, and they said, oh, yeah, you're right, we'll go right back out there and get the data. So, but it's important to have QA/QC, and obviously you're going to be using the data, so you'll see if there's any issues with it. Another challenge was it was difficult getting accurate height data from the imagery because we were measuring from the top, kind of the top edge of the pavement, and then we'd move over and kind of, you know, there'd be aggregate base, and sometimes there were washouts, so you couldn't really tell off of an image where that location, that point should be. And then also sometimes it was hard to tell exactly where it was in the image. So the images were high resolution, taken every 12.5 feet, but there were just some hardships with just using image data. So also what we found is that the cost to do extraction was roughly the same cost as having it consulted out. So one of the recommendations I have here is to rely on the experts. And I would just, in the future, which we're going to show our project we have going on now, that we're having the extraction done by a consultant. So, and using the LiDAR and imagery is another recommendation together. That will give you the most accurate results for any height or clearance measurements that are made on the attribute. Now, the other part of the project that Brad's going to go through is getting comfortable with the LiDAR data.
And I see we had a question about the segments that we collected, and these are the 3 segments that we chose to have the mobile scanning done on. One of them on your left is the 35W bridge corridor in Minneapolis. You know, as you're aware that we had the 35W bridge collapse, and then we rebuilt a new bridge in there, and when they rebuilt the bridge, they did a lot of installation of sensors and monitors and so forth, and we felt it was a good spot to collect scan data for that area in case somebody doing research would need some accurate measurements from that data. And then the middle slide was Highway 36 in this kind of the center of the metro, where we had a construction project going on where they were going to expand, rebuild a bridge, and some other things in there. And so we scanned that for new construction. We got a TIN file out of that one for the surface of the road so the designers could match in some existing things. And then the area on the right is US Highway 61 at I-94 going to 7th Street. And this was collected. We got a TIN model and some other things out of there. We've got a construction project coming up through that area in 2016 that we're going to do. And it involves a lot of ADA work, ramps and head crossings. So we scanned that area just for this upcoming construction project. So we had some challenges with the LiDAR and the recommendations, also like we did with the imagery. So our challenges were with the validation. There's a lot of traffic in these areas, and you know, being on the shoulders, it gets a little crazy. MnDOT did, you know, the QA shots, QC shots along there, but we should have piggybacked on the lane closure and traffic control that the consultants used, but we didn't. We went out there after the fact and yeah, it wasn't really safe for our survey crew to be out there just doing that. So, you know, we weren't able to check the targets like we wanted to, and some other points. I mean, we had some shots and we were able to check it and make sure that it was within specs, but yeah, it was a little close. You know, some of the specifications weren't real clear that we had put out there. You know, getting the number of survey shots and that kind of thing. You know, we didn't quite spec it tight enough, I guess you might say. And some of the challenges, as you see, you know, using a tighter spec for the LiDAR accuracy. We had it at 1/10 of a foot. Well, you know, when you're doing it and you aren't real sure of what you are going to get out of it because you're a newbie on this, then you realize that, boy, if we'd have spec'd this tighter, like less than 5/100 of a foot, we would have got a much better product out of it. It would have meant, you know, a higher cost and so forth, but it was needed for what we needed to do. And then we got all of the LiDAR information because we got the imagery in UTM coordinates. Minnesota uses a county coordinate system for all of our survey work. So we had a challenge getting it out of the UTM datum into our county coordinate system so that we could actually go and check this. So that's one of the things in the spec that we need to do and specify. And we also purchased recently MnDOT's software. We feel this is going to help us with our future QA/QC products. One thing about the benefits that we see, you know, with mobile scanning and imagery is that, you know, getting the mobile imagery is very fast and it's very cheap compared to, you know, other forms. And you can gather a lot of assets quickly. And like Trisha said, we had a lot of this information, and then you just set at the desk and crank it out as quick as you can. For our budget and our plan, you know, we need to view the assets and add to the project, you know, if replacement is needed of the older stuff that we have out there. And we have to make sure that this is in our planning for a project and that it's accounted for, so you can get this information, but we have to be able to use it. One of the things that we have in with our GIS database is a program that we have here at Metro. It's called Guardrail. And this was a free software that we got, and we modified it to how we wanted to have it used. And it's really a GIS viewer where we can get all the layers of all these assets. As you can see on the screen there, we have different assets showing up on the screen. And it's very quick, it's up to date, and it's a good tool for our different groups to use in planning and how we want or what we need to include and be aware of when we're out there. So as we get all of these assets collected, it'll help us better on a planning platform, I guess you'd say. And then, you know, expertise with the LiDAR. We're getting more and more experienced with the scanning and the data extraction each project that we do, and we're learning more things about how accurate we need to be, what we need for the QA/QC, and all of those type of things that pop up and you say, boy, I wish I would have done that, or we should have spec'd that tighter or changed that spec. So, and within MnDOT, you know, for the past about 12 years, I've been banging the drum, you might say, to get people to understand what laser scanning can do for them. You know, you can scan it once and then mine it many times, getting all sorts of data out of it. And, you know, there's the safety aspect, like Trisha mentioned, where I don't have to have my crews out on the roadways collecting this data. Scan it, pick it out of the scan, and use it. And we're finally getting some forward progress with the use of mobile scanning here, yeah, especially in the metro. Wave 5 we just did this past summer. There was no existing profile on this road. It's kind of rural out on the west side of the metro. And we had nothing in any of our old plans that showed a profile, so the designer needed to come up with it because they were adding turn lanes, they were changing grades, they knew there were some sight distance things that they wanted to fix, those kind of things. So we had a consultant come up and do the scanning, and they subcontracted out the targeting. And what we just needed from this project was just a tin model of the road surface. Added to that, we did Minnesota Highway 8 in the same contract, about 4.5 miles. This is once again in the East Metro, up near Taylor's Falls, Minnesota. If you're familiar with Minnesota at all, beautiful St. Croix River, as you can see, flowing through there. And it's a very tight area. It's curving, tree cover, and very narrow shoulders. But once again, the profile through there was not what it was when they had built the road. A lot of it is due to the road sliding a little bit downhill. It's cut, as you can see in the lower right, out of a cliff. And some of the fill on the downhill side is moved. And so they needed to know better where this road is. We had a lot of traffic coming out of Wisconsin onto this roadway. So we needed a good tin model for that. Excuse me. We also got the rock face along there. Excuse me.
Sure. The next project that was scanned was a construction project that's coming up this year. It's on 494, and surveys did a static scan of the roadway surfaces, starting first with bridge match areas, match-in areas, and then expanded to crossover areas, and further they included the whole roadway length. So that's kind of a good application in which they did some match-in. If they had known that this was going to expand so much, they would have just mobile scanned it. It was an unbonded overlay, and the deliverable was a tin model.
All right, see if I can not choke anymore here. Currently we're working on a huge project for us. It's the 35W at Lake Street project, and 35W in this picture runs north and south through the picture on the right of the screen. And Lake Street is a huge street collector in the city of Minneapolis. At the top also is I-94. We have the intersection of these two highways there. And it's two of the busiest roadways that we have in the metro here that come together. And when we actually closed this roadway down for design purposes, and that was the first time that any freeway of this size has ever been closed down to do design work. If we have maintenance work, those kind of things, they do it. But we actually got to close it down for 2 different weekends to do the northbound and southbound. And while it was closed down, we had Martinez Geospatial from Eagan, Minnesota, do the scanning. MnDOT survey crews did all of the targeting for it and did the random shots that we wanted. And what we're waiting to get from them is a tin model of all the surface and also the bridge clearances through there, because we're going to be doing bypasses and some unbonded overlay on part of it and different things out there. So we needed to know where the surfaces were and also all of the bridges. So we're waiting for that to be delivered to us. So now, if we rule the world, and Trisha and I, wish we could, but anyway, what's our vision for all of this? So I'd like to give credit right up front for these slides, pictures. BTN Engineering out of Las Vegas, and then Terrametrics scanning company out of Omaha gave me these pictures, or allowed me to have these. So what you see here in the upper left is just driving down one of the streets in Las Vegas, and then it was scanned, and then in the lower right, all of the above ground information was scanned, or was picked out of that scanning and had it digitized and so forth. And then also added in was all of the below ground information that they have, the blue lines, the green lines, red lines, and all all the, like the orange structures were added in for 3D. All of this is put together. They even added in things of those pink cylinders that you see were actually soil borings. They were looking for the blue water line that crossed the road there, and the pink cylinder to the right, they went down and figured that's where it should be. Well, they didn't find it there, so they moved and they found it at the other spot. So they needed to know where it was for accuracy. So putting all of this together with the scanning on all the below ground information makes it into a 3D process that can be used by lots of groups. So added to this, you can tag information to all of this, all these structures that you have. Example here is the underground. There's a storm sewer line that runs through there. And tagging this information, you can put in the construction plan when it was done. You can put in any standard plates that were used to show what type of structure was put in place. And you can add any repair data or anything like that that you want to put with each of these structures. Here, it's, like I said, it's only that storm line, but you could do it with the sanitary, the water mains, the light poles above ground. I mean, you could put it, tag it to anything that you want. And the nice part about this is then you can load it, all this as-built data, asset data, onto an iPad or an iPhone or a tablet, and you can take it with you into the field. There's a great video by VTN on YouTube that you can get this picture actually from. And those are real cars driving by in the background, and the asset information is loaded on the tablet. So as you move the tablet, the scene changes and the assets change. You know, you can use this information for design if they walk a project and they're looking at what they want to do, maintenance if they're doing repairs, slot drains and pipes and so forth. And so we're making really good progress on this. We've collected thousands of structures already. And then we're downloading this stuff into our HIDE-INFRA database that we already have. That database has information that was collected really rough by students, but we're doing it to, you might say, survey grade, so it's highly accurate, and then we can use this information in the future for any construction projects. So as the roads change, we're going to update that. This area is going to change when we rebuild this project area, and so then we will, you know, have the stuff that's there, but if anything got torn out and replaced, then we'll just update the database with all of that. So it's ongoing, and it's going to be fully 3D. We can use it in design, construction, and as-builts.
All right, thanks, Brad. Another effort we have is to obtain as-built via construction projects. As I described earlier, our budgets are staying the same and our roadway system is growing, so we need to be as efficient as possible. So what we did here is we established one unified specification and pay item that is going to be added hopefully to all of our construction projects in the Metro District. We started small, and so we wrote the specification to include 4 asset classes that were lighting, intelligent transportation, or intelligent traffic systems, signing, and drainage. We've implemented this as built into 6 projects in the metro area, and so far things are going very well. We are working to improve some communication about the specification and have some, you know, growing pains that way, but that's always the case. But over time, I feel they'll get very familiar with the specification and we will see improvement. The benefits of this are numerous. By using external resources instead of internal to obtain as-built, we're able to reallocate our MnDOT staff to work on other projects. The contractor is also physically out there doing the work, so they can readily obtain the underground and above ground locations at the right time before the trench is backfilled, obviously. Having one pay item instead of asking for as-built as incidental means that we can track all of our project costs associated with construction as-built, and we can also hold payment until we receive the as-built data. So using all of this data is also beneficial because of where those underground utilities are for our Go for State 1 call. which is required by state statute. And all of it can be used for planning and scoping purposes. Now, there is an idea that we could expand our as-built to include mobile LiDAR in the future, and that the mobile LiDAR would be the as-built, which I think there might be one or two other states doing that. So, you know, that could be a goal of very accurate as-built. We are now currently underway with what we're calling the Cadillac version project. And what this project does is it collects very accurate LiDAR data combined with imagery so that we can help several business functions at MnDOT. Those functions including bridge, maintenance, design, traffic, and safety. It's an 18-mile urban corridor along I-35W, US 10, and 694. And it's going to be mobile scanned by Continental Mapping. Continental will be delivering a full geodatabase of extracted assets and attributes, so we won't be doing it in-house. We'll have them do it, along with bridge clearances and TIN models from the LiDAR data. This corridor we chose because it contains several future construction projects, and that will consume those TIN models, and it also contains new segments of roadway that we don't have as-built for, and that we will put into our asset management database. All right, so now that we have the inventory and condition information for our barrier, how are we going to better manage the asset and the asset data? So what we're going to be doing, and we've kind of started down this road, but we're going to be tracking changes to the asset by pulling design line work from our MicroStation design software into GIS. So when the designers create a plan, and it's electronic, we're going to grab that line work, we're going to pull it into GIS, and we're going to set that data as pending and do some attribution to the data. Then we're going to take in the construction as-built or the survey as-built data, and we will align it basically to be at the correct location. Our maintenance crews obviously have been working very hard because when we have snowstorms, we have a lot of guardrail that's hit. And so we've actually been tracking that repair location and activities for, I would say, at least a decade. And so we will take that information and update the inventory with those ongoing changes. All this data combined will be supplied back to design using a web mapping service, so it completes the asset data cycle. As discussed earlier, we will also be able to do advanced analytics and reporting for barrier. Those things like age, condition, value, life cycle costs, and financial needs. The current plan is to include barrier in Phase 3. As I mentioned, we're on Phase 2 of MnDOT's TAMP. The sky is the limit, and I will let Brad finish this up.
To continue, you know, we need to do a complete program here at MnDOT. You know, to continue with scanning department-wide, we need to develop a systemic approach. You know, when do we scan? How much do we scan? Do we consult it out, or do we do it in-house? All those are just questions that we need to have answers to develop this systematic way of doing mobile LiDAR and imagery. And then we need to roll it out statewide, getting buy-in from the districts. Metro has started it because we saw the need and we've acted on it. So we need to then buy into the other districts. They have lesser of all of the assets that we're collecting, but still they need to know where it all is, and it helps in the big picture of things for funding things that we take to the legislature and the governor. And then using this approach, you know, we need to work to meet our business needs of the future. Some of those things we don't even know what we're going to have in the future just because of all of the stuff that's coming down the pike with road projects and that. But the main thing is to, you know, get our assets all figured out as to where they are. So that's it for our presentation today. Does anyone have any questions or feedback? I see we've gotten some on the chat line.
Yeah, thank you for connecting with us today and listening to the work that we're doing. Everything is always a work in progress, but I feel like we've really learned a lot, and we've also, utilized some of the other work by other states in order to do this. And I'm always kind of on the lookout to share information. So there are emails on the screen, and I think then we'll turn it back over to Dick for some questions.
Yeah, so we've got a few questions I see that came up, and I'll just kind of run over some of those, and I'll let you answer them. First off, NCHRP report 748, which is guidelines for the use of mobile LiDAR in transportation. Did you use that? Did you find it useful as you were going through the process?
I was just kind of racking my brain because I do remember that report. I wonder if that was in 2012 or so. I think what we used out of that report is, and I don't know if people want to chat back about this, but there was a table of kind of which accuracies you should have to what business needs. And I think that's where Brad and I really started thinking about how many needs can we meet for what this is going to cost. And so where do we want to fit in with this project? And we couldn't meet all the needs, but we could meet some of the needs. So I remember looking at that table and sort of, and then also there were really good kind of vague, I wouldn't say vague, but there were really good guidelines in general for how you would go about this. And so, yeah, we did utilize that. Good question.
Okay. A question on how long did the extraction take in terms of personnel hours, and did the personnel need to be trained first before they did that?
So I had 1 or 2 people working on this, but basically 1 for the most part, for about 3 straight months. And that's how long it took to do our roads in Minnesota. And they were not trained previously. They had GIS experience, and so that was something that they knew is the GIS world. But otherwise, they did not have any Trimble Trident analyst training. They hadn't done any desktop extraction or surveying. So we really had to rely on the consultant for that work. And Data Transfer Solutions, still to this day, will answer a question from me within probably 5 minutes. So, and then also Trimble was really supportive to help us through that process. So it would be nice to probably take some formal training and have someone that was maybe more had a license or something. I don't know if there is that out there, but we did not have that.
Okay. All right. Another question is, what mobile mapping system was used and how many scanners did you have?
They used the MX8 scanning system, and I'm not certain how many scan heads they had on that.
Okay.
It was the Trimble MX8, but I don't know either. I can't remember if that just has a.
Well, it can either have 1 or 2, and I'm not certain how many they had.
Well, did you have just one vehicle that's equipped with these scanners then that collected it?
Yeah.
Okay.
Right.
Okay. What level of staff expertise does MnDOT have for utilizing LiDAR data sets or deliverables for QA, QC, future data mining, etc.? Is there any suggested training that you have?
Yeah. We're newbies on the data extraction. Trisha had some students pulling that information out from the imagery. The Metro Surveys group has taken some training. Like I mentioned, we purchased TopoDot software to start extracting out the tin lines and the other features that are tin models and the other features that you can get out of scanning. But our photogrammetrics unit down in our central office has got a lot of experience using different types of data collection, things like aerial LiDAR and photogrammetric work and stuff. So they're starting to take a bigger lead in this and pulling extraction information from all of this. But it's basically self-taught, or the consultant or the vendor teaches us how to do this.
Okay. Now this is my question that kind of piles onto that one. It seems like with all the stuff to get it all in your perfect world that you'd almost have to have almost everyone in the DOT have some level of proficiency, from the maintenance people that might be making changes to your utilities and your permitting people, to your construction people, to your design people. So is there something that you're doing to try to make sure that all of the staff that's going to have some role in maintaining this in the future has some level of proficiency?
Well, the data collection is the easy part. Then you need to have somebody process that information to get it into the databases using various software packages that we have. So, I don't know exactly what level. It's the world that we want, so we're just starting into it. We're gathering all of this information. All of this technology keeps changing as we go along. So,
if you're talking about just asset data, we have several systems that we are databases that contain and hold our asset data. And so when we ask for, let's say, as-built from the contractor, we're asking for that data in a relatively easy to implement format. So we have lots of people that are able to do that. But when it comes to the expertise of maybe using the LiDAR, using point clouds, doing some extraction of tins, that's where we really don't have as many people that are experts, and I think that's okay. I think that works.
Okay. Right. If we start getting it more into the 3D design, where we're going to actually use the tin models right in MicroStation for the designers to start pulling information out of, then there's going to have to be more training, getting into the 3D world and being able to do those kind of things. So we're going to have to get our design group up to speed, actually some more people in surveys up to speed, to make sure that we collect it correctly and to the accuracies that are needed.
Okay. All right, there's a question. What was the interval of control targets?
For our 35W project that we set the control on, it was around 600 to 650 feet. We had a little leeway, you could move it in to get into a better spot, and it was on both shoulders of the road. For the Highway 61 project that we did the targeting for, those were every 660 feet, once again on both shoulders of the road.
Okay. Was some of the data collected using aerial LiDAR? And if so, which parts?
No.
No,
not in anything that we presented. We do do aerial mapping and get tin models from that, and then if we scan a highway, then we cut the scan part, the tin model from it, and paste it into the aerial stuff, so that we get a tighter roadway section for the designers.
Right. Was this helpful in tunnel systems? Did you go through any tunnels?
We do, yeah, we do have some tunnels, but we didn't collect LiDAR.
Yeah, we have, but I haven't seen it on the 94 or the 35W and 94 interchange. There's a couple of tunnels there. I have not seen any information back from our vendor on that one yet, consultant. It's coming.
Okay.
Contact Brad in a couple months.
Yeah.
Okay. All right. Let's see. A question on what is the significance of the points placed for guardrail? Is it the posts, the guardrail sections, both?
Can you say that question again? What is the significance?
Significance of the points placed for guardrail. So did you go through and identify points? Did you line them up with posts, or was it just
Yep.
Routine spacing, or?
So we started at the end treatment. I think it was the bottom center of the end treatment. And then we did about every 5 posts, 5 to 10 posts, we took a point. I know there's more posts at the beginning of where the end treatment is. And then we followed along the plate beam in the very center at the bolt. And that's actually a really good question, because you want to specify exactly how you're doing the extraction, exactly where the points to be taken, exactly, so that if you have somebody else coming and doing it, or you have several people, they're doing it very consistently. And we chose that to be the easiest way to see what we were doing. And so that's where we do the line. And then at the barrier, the concrete barrier, we took the points at the very top of the barrier. And we did that, I don't remember the interval off the top of my head, but it was every so many feet.
Okay. Let's see, I have a question. How do you prioritize the highway infrastructure elements that you inventory?
Yeah, that's a really good question. I think pavements and bridges have been always kind of at the top of the list. Obviously, because of MAP 21, that's the case as well. Then after pavements and bridges, I feel like, let me just grab the slide. I could go back to it here, but it's whoever's got the loudest, whoever can be the loudest. No, I'm just kidding. Signs really were kind of a close second to that. We have a lot of individual groups that feel strongly about asset management and that have tried to kind of do an inventory on their own. But we basically did pavement, bridge, then we did signs and signals. We just had 1 point at the center of every intersection, and now we've gone back and actually gotten all the signal poles. Lighting, I think, was shortly after that. I can't tell you that we prioritized based on, maybe it was safety related. I mean, signs, we wanted to see where they are and if they're meeting retroreflectivity and all that. But really we had, then we went next to the ADA assets, or the pedestrian assets, and that came out of the pedestrian improvement plan that was created. So some of this, I would say, would be because of federal regulations, and some of it just if people had staff within their area to do some inventories, then it happened.
Or money.
Or money. Yeah, money's, and so as you can see though from our list, you guys, the concrete and guardrail has been a lower inventory item on the priority list, and I think every agency is facing that and seeing that. And so again, we just completed it, last year, this year,
But all of this, helps paint the picture when we go to the legislature asking for money and explaining that, we have all of this guardrail and it's so many hits, so we have to fix so much of it each year, those kind of things. So it helps, tell our story, having all of this inventory.
Okay. All right. Let's see. How difficult is it to use LiDAR data in-house?
Well, we're kind of getting new on it. I mean, the projects that I showed you, the most of them, we've had the consultant extract the tin models and those kind of things for us. And so, like a tin model, we can use that right into MicroStation. We're just getting our own troops up and going with TopoDot so that we can extract from the mobile LiDAR information. Pulling out the curb lines, all the brake lines that you need, and the tins, and doing that kind of stuff ourselves. So we're just getting going on it in-house. I have about five people, I think it is, that are working on it.
Okay. Let's see. Here's a question about the accuracy. What was your plan for control to achieve a 1/10 of a foot accuracy, and what would be your control plan to achieve 5/100ths of a foot accuracy?
Okay, for doing the targeting for 1/10 of a foot, you could just do that with an RTK and get that check, do your checks and stuff for that, and that should get you within the 10. But if you're going to get something that's less than 5/100 of a foot, you can use the RTK to get your XY because it's really tight, at least here in Minnesota. But the vertical is always the problem. So we actually used total station instruments coming off of our geodetic benchmarks and control work and actually leveled through each of those to get an elevation that's down to the 100th or 200th of a foot accuracy. So using that for the targets. It's the only way that you're going to get something less than 5/100 of a foot when you scan.
Okay. Let's see, is your GIS database completely 3D or a mix of 2D and 3D?
Oh, our GIS database is really, it's a mix. So we do have some Z elevations in some of our drainage structures and other things, but for the most part, it's a two-dimensional. Yep. It's kind of where we're headed would be to use 3D. Where we are right now is mostly 2D.
Okay. All right. Another question: did you include any condition assessment during the process of inventorying?
Yep. So we did condition points. The condition values were for plate beam to see if there was a broken post, if there was some rust on the plate beam, if there was some plate beam that wasn't functioning. And then for barrier, we looked at spalling, we looked at any water issues, and we basically just set points and then looked at the data, and our maintenance crews did work as needed. That's something about barrier that's a little bit different is, how long does it last? I mean, we kind of have it out there for a very long time. So the condition information maybe isn't quite as important as other assets. And plus our maintenance crews are constantly fixing and looking at the guardrail and seeing the guardrail condition, and if something's not right, they're improving it. So, but yep, that was the condition information. I think we took 250 points throughout the Metro District on condition, I would call issues.
Okay. Let's see, this question, I'm trying to understand it myself, but I'll just read it. When you contact the vendor, what mobile mapping manual you use as a reference for communication with the vendor? Does that make?
We don't actually use a manual. We have kind of our own specs now, through our trial and error here, and it all depends on what we're looking for. Like Trisha and I, if we rule the world, we start looking at all of our assets and all of the stuff that we can collect. Do we need it super accurate, like for the road surface? Or is there like 95% of the stuff we can collect, is that good enough to, a couple tenths of a foot? Is that what we need? So we kind of look at that and write the specs accordingly. Now, like I said, we've got several of these projects under our belt. We feel we're using that. But we also are looking at other states, their specs and the national specs and so forth along with it.
Okay. What format is your as-built data in?
Well, we asked for UTM, I think, for our projects for the asset information, and then it is in just an ASCII. We also accept shape files or a geodatabase.
And then we get the LAS files for the scanning information.
Okay. Are you using AutoCAD aligned with LiDAR in this process for the asset collection and or updating?
We're a microstation shop.
Okay.
So everything that we do is in microstation.
Okay. Have you considered incorporating RFID tags into the data collection process? If so, please expand on this.
You know, that was, I have another gentleman in the room with us right now to, if there was any questions kind of related to maintenance activities. If you want to.
What was the question?
It was, have we looked at RFID tags?
We have, and I think the cost, we looked a few years ago and they had told us no, but I think it's going to be coming back around again to put on. I believe they're using them on our light poles right now, and we were looking at using them on guardrails.
Yeah, so I think that should be something we look at again, because I know that it was relatively, what was that, 3 years ago?
2-3 years ago.
And it was a lot of the cost, and I know the technology has really come around. We are trying to be as efficient as possible by, we're not necessarily tracking our guardrail components at the inventory center, but we are tracking the location based on, again, the microstation plans and then the as-built data from the contractor, and then we're verifying that that's actually what's in the field. So we can track those attributes, I would call them, maybe not every single component from the inventory center, and that would be nice to do in the future.
Okay. Let's see, this gets into the costs and whether you've figured out what an average cost per mile for high accuracy LiDAR and imagery or cost per mile for asset extraction.
Do you want to talk generally about
our contractors? Well, the contract that we're letting on 694, 35W, and 10, the Cadillac version, it's roughly $10,000 a mile is what we've got for a bid on that, where you know, they're pulling out everything. They're doing the scanning, they're doing the targeting, all the control work, and then all of the extraction into the databases. So they're doing everything, and so it's coming in around $10,000 for each mile of that. Now, some companies maybe can use it or do it cheaper. Some of the bids that we got on the RFP for that were kind of extravagant, so it kind of all depends. So right now the award that we got was about $10,000 per mile.
And the project that we had for Guardrail, it was a $250,000 project, and that was over the entire Metro District at 1,100 miles. And that was kind of a conglomerate, like we talked about, of imagery and LiDAR, but only 3 segments of LiDAR. So getting the imagery is less expensive, I would say, but then we also did in-house extraction, and I was kind of doing some math. And it was relatively, you know, it cost us $20,000 to do the extraction with students and one other staff. But we also, that doesn't include overhead, so I didn't really take into account all the overhead rates with that. So that's a relatively low number. But what we did find out of the project is that it's about the same price to really have the consultant do the extraction. And that's where we are with the 35W US 10 694 project.
Okay. Right. Let's see. A couple more questions here. How do you handle the collection of complex guardrail strings, such as those that wrap around medians or other routes?
You know, I think it's from image standpoint and from extraction, we would just do it relatively the same way, where we take points every post, and then we do it from one direction of the drive, and then when we're coming back the other way and we see the imagery on the other side. In the software, it's relatively easy just to, you know, make that line kind of continue. So a bull nose, is that what maybe they're talking about? Yeah.
I believe so.
Yeah, we didn't really find that to be too difficult.
Okay. Was this useful in conducting pavement condition surveys? Have you tried using it for things like that?
No, we haven't got into that. I know we have a van here in the Metro that does the pavement conditioning, and I'm not exactly certain how that works. Maybe Trisha?
Yeah, we actually have a van that used to be at our Maplewood lab, and so our Maplewood lab has 2 vans that drive all of our roadways once a year, and they collect imagery that it's not imagery that is high resolution. So we use it as called our video log. I think other states have that. Then they do collect, they have cameras facing downward that collects pavement information and condition. I think just in the last 6 months or so, they're investing in LiDAR technology to look at the distresses on that pavement. Previously, they had one gal that would just do, the first 500 feet of every mile. She would do the calculation and populate the database for the distresses. But they've invested in, and I could get you more information if you want to email me or want to know more about that. But I don't know what technology that is or about that LiDAR. But it's a good application for LiDAR.
Okay. I think you answered this next question already, but we'll throw it out there. Does the GIS shapes have Z coordinates, and if so, do you use them in 3D GIS viewers?
Well, so the guardrail would have a Z coordinate, but we're really not utilizing that coordinate information. We're utilizing it for our drainage structures in which they have a Z coordinate on the pipe within the structure. And for design purposes, that's important, very important. But I would say for guardrail, no. Right now we're focusing on two-dimensional and asset management approach.
Okay. See, what factors do you consider whether to purchase and deploy MTLS system in-house versus contract for those services from a consultant?
Could you read that again? I was trying to figure out something.
Okay. What factors did you consider on whether to purchase and deploy MTLS system in-house versus contract for those services from a consultant?
Okay. When it first came out, when I first saw it at a conference, mobile scanning vehicles and stuff, I was all gung-ho that we should buy one for Metro. Then I got the price tag of $1 million, and everybody said, yeah, no. We're not going to give you that kind of money. And then upon thinking about it, this technology is changing so rapidly. Scanners that used to collect, 1 million points a second are now collecting 100 million points or whatever it is a second. So the changes in the technology is, we would have a 2-year-old scanner that is, worth $1 million, and now you could buy something for $500,000 that would collect 10 times the number of points and things. So with all of the changes in technology and also the changes in software, we kind of looked at it that we're going to have the vendors do that for us, the scanning. We're going to dabble in the extraction, with the Trimble software we had and the TopoDot software that we had. And then we're going to do the QA/QC by using our softwares on it and then checking scanning out in the field. But basically right now, until something different happens or whatever, we're just going to have vendors doing the scanning for us.
Okay. There's quite a few questions, and I think we only have about 5 or 6 more minutes left on here. So I'm going to kind of, the ones that I think we've already kind of answered a version of, I'm going to skip over those for now. And then I think we can review these questions and maybe give out some answers later. Is that?
Sounds great.
Sound okay? Okay.
It's good to see so many questions.
Okay. Have your contractor used control points at all in data collection process? Has your contractor used control points at all in data collection process?
For the scanning, yeah. Where we needed the Type 10 models for design and stuff, the contractor subcontracted that out to a surveying firm to get the targeting down. And I did see a targeting question about what type of target we use. Depends on the vendor. Some of them like an X, some of them like a chevron pattern, and then the orientation varies with each one. So you got to deal with each one of them.
Okay. Did you notice any difference in intensity range between different scanners on the LiDAR? think you might have said you had maybe 2 scanners. Was there any difference between those that you noticed, or?
I guess we haven't looked at that, no. We've only been dealing with the end products that we've gotten, and I guess you know, maybe the guy that does my internal processing of our static scan work would notice something, but I'm not aware of it.
Okay. There's a question on what firms are actively working on this project for you now.
Well, our 35W project is Martinez Geospatial out of Eagan, Minnesota. Our 69410 35W project is Continental Mapping. They're out of Sun Prairie, Wisconsin. We've used Terrametrics out of Omaha, Nebraska. And
we mentioned Data Transfer
yes.
Solutions. That was the Guardrail project, and they're out of Florida. Facet Technology and SRF Consulting did the sign inventory.
Right.
What are we missing? I hope we're not missing anyone. Sorry
Right.
if we are.
I'm racking my brain trying to figure out. I think that's the ones we've used so far.
Okay.
We had a lot of other companies put in on the RFP also. We could give a list of those, I guess, if people wanted to know.
Let's see. Have you had any experience using the data from lower grade mobile LiDAR, asset grade mobile LiDAR, as you mentioned before, that you used Trimble MX8? I believe it is design grade machine. So have you used anything lower grade, I think is the question.
Yeah, I think Facet Technologies for the sign inventory contract used a lower planning grade level LiDAR. I was pretty new to that, and I'm not sure what those specifications are at this time. But again, that's a good way to go if you're looking at getting, just something kind of in the middle, I would say. So you're not as high density, and it doesn't take as long maybe to process it, but you're not looking for the real accurate information. If you're looking for planning level.
Yeah, you got to use the high-end stuff for where you're looking for, under 500ths of a foot. The other thing too is, figure out what you need, figure out what accuracy you need, and then put it together in an RFP, and the people will pop up out of the woodwork to come up with, what they can do for you.
Okay. Let's see. There was a question about. I'm gonna find it now. Did you decide to use TopoDot because the consultant uses that software?
I know a bunch of consultants use that software, and I've seen several demos of different softwares, and that one seemed to fit the need that we have currently here, and so we're just getting into using that.
So did you specify it, require it, or was that what the contractor proposed?
Neither. I'd seen it. I knew that we needed to do extraction, and like I said, based on different demos I'd seen of different software, TopoDot seemed to be good, and then I just went to my boss and got the money, and we bought it.
Okay. I think I'll just grab one more of the questions here, and let's see, I guess, what are your plans for updating, maintaining your GIS asset inventory database? More scanning for change detection? There were 2 questions there.
So that was something that I covered with, we covered with the as-builts. We're going to continue to obtain as-builts from construction projects, and then maybe in the future we would ask for an as-built of mobile LiDAR in which we could then update our asset databases. I'm not familiar with change detection right now, but I see that could be an option for us in the future.
We've actually done some in-house scanning with our Leica scanner, change detection on a wall. I know that they thought was failing or moving or whatever, and so we have done some of that stuff where we scanned it and then we waited a couple of months and scanned it again.
Okay. Well, I think we're getting right up to our time, so I think we need to go ahead and cut it off. Again, there might have been some questions that we weren't able to get to, and I think Trisha and Brad will try to take a look at those, and maybe we can send out some responses on those. I do want to thank Trisha and Brad for their time and a lot of good work that's going on here. I'm very encouraged by everything that I'm hearing in this regard. I think we definitely need more information and data like this. So I'm hoping that some of the states that are on the line will see this and say, hey, we want to try that too. So again, thank you, Trisha and Brad, for your time and telling us about what's going on. This webinar has been recorded. You'll get all the participants will get a link to the recording and the presentation that they can download. With that, I'd like to thank everybody for participating. I think we had a really good turnout here. And again, thanks to Trisha and Brad for their time.
Thank you.
Thank you.
Right.